Imagine standing on the moon. The Earth is a fragile blue marble in the distance, and you feel the weight of history beneath your feet. It seems almost effortless now, humans walking on the moon, but let me tell you, it was nothing short of miraculous. What we achieved in 1969 was so improbable that, by the laws of physics, engineering, and human endurance, it should have been impossible. Yet somehow, humans did the impossible. And today, we'll explore why. Imagine the sheer audacity of what humanity attempted. In the 1960s, to leave the cradle of Earth, that delicate blue planet, and venture into the dark, silent void of space heading toward a celestial body that had inspired myths and dreams for millennia. At first glance, it seems almost naive, almost reckless. After all, the moon is not merely 238,900 miles away. It is separated from us by the unforgiving vacuum of space, by radiation that can fry unprotected electronics and living tissue, and by the relentless pull of gravity that holds us firmly, safely upon our home planet. The challenge was not just monumental, it was, in every sense of the word, staggering. To leave Earth's surface, a spacecraft had to reach what scientists call escape velocity, roughly 25,000 miles per hour. To imagine this is to think of a baseball, a simple object being hurled with such force that it breaks free from Earth entirely, never to return unless guided. The precision required is mind-boggling. If a rocket is off by even a fraction of a degree, it could spiral endlessly into space, missing the moon by thousands of miles, or worse, be pulled back into Earth's atmosphere in a fiery return. Every calculation, every adjustment, every maneuver had to be executed with near perfect accuracy, because in space, small errors are magnified into catastrophic failures. The challenge was compounded by the fact that these missions had to be timed precisely. The moon, while appearing to hang frozen in the sky from our perspective, moved constantly along its orbit. Launch windows were narrow, sometimes mere seconds were all variables Earth's rotation. The moon's position, the spacecraft's trajectory had to align perfectly. Missing that window would render the mission impossible. This is not speculation. It is the cold mathematics of celestial mechanics, where even a small misalignment could lead to the destruction of the entire venture. And yet, humans stood at the edge of this daunting abyss and decided to leap. Layered upon the gravitational challenge was the technological landscape of the 1960s, which is almost laughably primitive when compared to the devices we carry in our pockets today. The computers that guided the Apollo spacecraft were less powerful than a modern calculator, and yet they were tasked with calculation so precise that they determined whether humans would step safely onto the lunar surface or be cast adrift into eternity. There was no GPS, no high-speed internet, no satellites beaming data continuously. Navigation was based on a combination of manual calculations, analog instruments, and sheer human ingenuity. Engineers had to anticipate countless variables: the behavior of fuel in zero gravity, the minute effects of solar radiation, electronics, the unpredictable reactions of materials in extreme temperatures ranging from blistering heat to freezing cold. Every design had to be tested, every system redundantly safeguarded, because a single failure could mean disaster. The Saturn V rocket, the colossal vehicle that carried astronauts toward the moon, was itself an engineering marvel. Standing taller than a 36-story building and producing thrust equivalent to 160,000 horses, it represented the culmination of thousands of brilliant minds working in concert, all operating with the understanding that even the smallest misstep could cost lives. It is almost poetic to think that an object of such enormity and power had to be balanced and guided with the same precision as a hand-carved timepiece, because in space, chaos waits for the slightest error to pounce. The human element cannot be overstated. Astronauts, trained to near perfection, were sent into an environment that is inherently hostile to life. Our bodies evolved under the protective blanket of Earth's gravity, atmosphere, and magnetic field. Beyond that cocoon, there is only danger. In microgravity, muscles and bones weaken, the cardiovascular system is stressed, and orientation becomes disorienting. Exposure to cosmic radiation can damage DNA, potentially causing severe illness or death. And yet, these men and women, equipped with nothing more than a pressurized suit, a spacecraft, and extraordinary courage, endured these stresses with remarkable resilience. The technology may have been primitive by modern standards, but it was the human spirit that made the mission possible. Astronauts trained for years in simulators, enduring conditions designed to mimic every conceivable challenge, from fire and rapid depressurization to equipment malfunctions and navigation failures. They were conditioned to perform under pressure, to remain calm when faced with situations that would paralyze most people with fear. The psychological demands were staggering. Knowing that a single mistake could mean death for themselves, their crewmates, these pioneers displayed an extraordinary combination of focus, intuition, and composure. Even the physical design of the spacecraft had to contend with forces that are difficult to imagine. During launch, the astronauts were subjected to acceleration many times greater than their body weight, pressed into their seats with a force that could crush organs and bones if not properly countered. Every screw, every valve, every weld in the spacecraft had to withstand these forces while simultaneously operating flawlessly in the vacuum of space. Engineers and scientists had to predict how materials would behave under stress, knowing that failure was not an option. There were no second chances. The lunar module, the small craft that actually landed on the moon, had to perform a controlled descent onto an unfamiliar surface, often relying on visual cues and rudimentary instrumentation. The moon's surface was uneven, covered with dust and rocks, and no one could say for certain whether it could support the weight of a lander. Yet, the astronauts landed precisely where intended, touching down with minimal fuel remaining, a feat that combined meticulous calculation with the most delicate piloting ever attempted. This dance with gravity and technology, with the human body and the harshness of space, illustrates why the moon landing was so nearly impossible. It was not a single factor, but the convergence of countless variables, each of which could have doomed the mission. Every trajectory, every timing calculation, every engineering design, and every human decision had to align perfectly, like a symphony conducted on a cosmic scale. The beauty of it is that this impossible sequence of events was achieved not by luck alone, but by the combination of human intellect, creativity, and courage. Yet, perhaps what is most astonishing is the humility with which these pioneers approached the task. They understood that they were standing at the edge of the known universe, that their success was contingent on hundreds of interlocking systems, and that any miscalculation could render all effort meaningless. And still, they proceeded, driven by the fundamental human desire to explore, to reach beyond, to touch the unknown. They were aware that the moon was no longer just a distant rock in the sky. It was a destination that required the utmost precision, the most advanced technology available, and the steadiest nerves. Every decision, every adjustment, every calculation was performed with an acute awareness of the stakes. The gravity of the challenge and the limitations of technology did more than test human skill. They defined the limit of possibility itself. They forced humanity to innovate, to push beyond what was considered achievable. Engineers and scientists had to invent new materials, new propulsion methods, new navigation systems. They had to visualize a future that did not yet exist and then create it. In doing so, they expanded the boundaries of human knowledge and capability, showing that even in the face of overwhelming odds, the combination of intellect, determination, and courage can transform the impossible into reality. The moon landing, therefore, is not just a story of technological achievement. It is a story of human audacity, of reaching beyond the constraints of our time, of daring to step into a void that no one had ever survived before. Imagine the human body, a marvel of biological engineering, suddenly placed in an environment utterly hostile to life. Space is not merely cold or silent. It is a vacuum where air itself does not exist, where radiation from the sun and cosmic rays streak invisibly through the void, and where gravity, something we take for granted every day, is almost absent. Our bodies, evolved over millions of years under the comforting embrace of Earth's gravity, are delicate machines. Bones are designed to bear weight, muscles to fight resistance, and our cardiovascular system to circulate blood in a precise balance. Remove gravity, and this delicate equilibrium begins to unravel. Muscles weaken and atrophy, bones lose density, fluids shift toward the head, vision can be distorted, and even the simple act of moving becomes a challenge. The astronauts of the Apollo missions were acutely aware that their bodies were not optimized for this environment. Every moment spent in microgravity was a test of human resilience. Yet, despite these physical vulnerabilities, they endured. They trained for months, even years, in simulated weightlessness, in neutral buoyancy, tanks filled with water, and in centrifuges that mimicked the forces of launch. Every exercise, every simulation was designed to prepare them for the harsh, unforgiving reality of space, where even the smallest error could have catastrophic consequences. But surviving in space is only one part of the challenge. Operating effectively in space is another. Human cognition and decision-making are exquisitely sensitive to stress. Imagine being pressed against your seat, the roar of engines shaking your very core, knowing that any miscalculation will lead to disaster, while simultaneously navigating instruments and controls that must function perfectly under conditions that defy ordinary human experience. The astronauts faced not just physical trials, but profound psychological challenges. Isolation, confinement, and the constant awareness of mortal peril can induce anxiety, disorientation, and even panic. Yet, these pioneers displayed extraordinary composure. They were trained to remain calm under pressure, to think critically and make split-second decisions, to adapt to unforeseen circumstances, and to act with precision when the margin for error was vanishingly small. The human mind, in these conditions, becomes both a tool and a weapon. It must be capable of extraordinary focus, yet flexible enough to respond creatively to the unpredictable. The astronauts demonstrated that the human spirit can rise to the occasion even when faced with extreme danger and uncertainty. As they ascended into space aboard the Saturn V rocket, the physical demands reached their peak. The launch subjected them to accelerations multiple times the force of gravity, pressing them into their seats with a force that could crush internal organs if not carefully accounted for. Engineers had to design seats, harnesses, and life support systems capable of protecting the astronauts while allowing them to function and operate complex controls. The vibrations alone, known as pogo oscillations, could have shattered the spacecraft or rendered instruments useless. Every component of the rocket and the capsule had to withstand these forces, not as an abstract calculation, but as a literal guarantee of survival. There was no room for error. The design had to account for every imaginable contingency: structural integrity, temperature, extremes, fuel behavior, electrical stability, and redundancy of critical systems. The human element was inseparable from the technology the astronauts were. Both passengers and participants intimately involved in the success of the mission, relying on their training, intuition, and discipline to complement the precision of the machines that carried them. Once the spacecraft reached lunar orbit, the challenge intensified. The lunar module, a delicate craft designed solely to descend from orbit to the moon, surface and return, had to perform a maneuver unlike any humans had ever attempted. It was essentially a flying teardrop of aluminum and titanium with minimal fuel reserves, navigating toward a surface that was in many ways unknown. The moon's surface, although observed through telescopes, could not be fully mapped for landing hazards at the scale required. Dust could behave unpredictably. Rocks could puncture or destabilize, and subtle variations in terrain could lead to catastrophic tipping. The astronauts had to manually pilot the lander, using both instruments and visual observation to find a safe landing site. The balance between fuel management, descent speed, and navigation precision required a mastery of physics, a calm mind, and nerves of steel. Every second of the descent was a test of human judgment, integrated seamlessly with technology that, while sophisticated, lacked the automation we take for granted today. And then there is the concept of redundancy and contingency planning. Engineers knew that even the best designs can fail, and they built the mission with layers of backup systems. Oxygen, power, navigation, communications, and propulsion were all equipped with redundancies. But redundancy alone is not enough. The astronauts had to know how to operate each system, understand failure modes, and make critical decisions when systems deviated from nominal performance. This required rigorous training in simulators that recreate every conceivable emergency scenario. They practiced engine failures, cabin depressurizations, and communications blackouts. In space, when seconds can mean the difference between life and death, training must be absolute, instinctive. The combination of engineering foresight and human preparedness transformed what could have been a catastrophe into a carefully orchestrated ballet of precision, adaptability, and courage. What makes these feats even more astonishing is that all of this was accomplished with technology that, by modern standards, seems almost primitive. The Apollo guidance computer had less processing power than a modern wristwatch. It required astronauts to input sequences manually and interpret data without the benefit of real-time telemetry or automated decision-making. Yet, within these constraints, the system was designed so that humans and machines worked in harmony, complementing each other's strengths. The astronauts were not merely passengers, they were integral components of the navigation and decision-making process, translating abstract data into real-world maneuvers, solving problems that no algorithm alone could handle. The elegance of this interaction between human cognition and technological capability demonstrates a fundamental truth. Even in the face of extreme challenges, human ingenuity can compensate for the limitations of our tools, expanding the realm of what is possible. The psychological resilience of the crew was mirrored by the meticulous planning on the ground. Mission control in Houston was a hive of activity, coordinating every aspect of the flight in real time. Teams of engineers, scientists, and technicians monitored telemetry, calculated trajectories, and advised astronauts on corrective actions. Communication had to be flawless, yet it was conducted across hundreds of thousands of miles with a time delay and under the constant pressure of knowing that a single miscommunication could be fatal. Every decision was filtered through layers of calculation, simulation, and human judgment. The moon landing was therefore not just a feat of individual skill, but of collective human effort, where the talents of thousands converged to transform an improbable dream into reality. In examining these factors, one begins to understand why the moon landing was almost impossible. It was not merely the technical challenge or the physical dangers that made it so. It was the convergence of human physiology, psychology, engineering limitations, and the unforgiving realities of space. Each element alone posed significant hurdles, but together they formed a gauntlet so exacting that failure seemed inevitable. Yet, through extraordinary preparation, resilience, and courage, humanity succeeded. The moon landing stands as a testament to what is possible when intellect, determination, and audacity converge, demonstrating that even the most formidable obstacles can be overcome when we harness the full potential of our minds and bodies. Consider for a moment the precision required in timing a moon landing. It is one thing to escape Earth's gravity, to survive the vacuum and radiation of space, to navigate with imperfect technology, and to maintain human composure under unimaginable stress. It is another thing entirely to align your journey with the celestial mechanics of the moon itself. The moon, serene and unchanging to the casual observer, is in constant motion, orbiting Earth at nearly 2,300 miles per hour. Its position in the sky at any given moment is a function of its orbit, Earth's rotation, and the relative motion of the spacecraft. A launch must be calculated not merely in hours, but down to the precise second. For a delay of even a few minutes can place the spacecraft outside the narrow corridor necessary for a successful trajectory. If the timing is off, the lander may miss the moon entirely, or it may approach at an angle that makes landing impossible. This is not conjecture, but pure orbital mechanics, where slight errors are amplified across hundreds of thousands of miles. Engineers had to account for gravitational influences not only from the Earth and moon, but also from the sun and other celestial bodies, calculating trajectories with the precision of a cosmic clockmaker. Every maneuver, every burn of the rocket engine had to be executed exactly as planned, and all of this with computers that are laughably limited by today's standards, less powerful than a modern smartphone, yet capable of solving problems that would have been insurmountable with human calculation alone. Now, layer upon this the human factor, the astronauts themselves. These pioneers were tasked with executing maneuvers within these tiny windows of opportunity. A split-second misjudgment, a hesitation, or a misreading of instruments could have resulted in catastrophe. They were required to integrate calculations, intuition, and training in real time, acting as a living complement to the guidance computers. The tension was almost unimaginable. A journey of hundreds of thousands of miles take days, where the moon's position dictated the success or failure of the mission. There was no room for improvisation beyond the carefully rehearsed contingency plans, yet the astronauts demonstrated an extraordinary ability to adapt, to anticipate the motion of celestial bodies, and to act decisively. The timing alone highlights the improbability of success. It is a reminder that the moon landing was not merely a triumph of engineering, but a triumph of human foresight, discipline, and courage in perfect harmony with the laws of the cosmos. Beyond timing, there is the profound psychological and physical pressure that astronauts endured, a crucible in which ordinary humans might falter. Imagine the weight of responsibility, knowing that any single error, whether a miscalculation, a mechanical failure, or a misjudged maneuver could end your life and the lives of your fellow crew members. The human brain is remarkably adaptable, but extreme stress impairs memory, judgment, and reaction time. Astronauts were trained to override these natural responses to remain calm, analytical, and precise under conditions that would overwhelm most people. Isolation from Earth, confined quarters, continuous exposure to danger, and the monotony of long transit periods created psychological conditions akin to what explorers experience in the most remote and hostile environments on our planet, only magnified by the knowledge that there is no sanctuary, no rescue, and no margin for error. The ability to maintain composure, focus, and effective decision-making under these circumstances was as critical as the performance of the spacecraft itself. Human resilience, mental fortitude, and the capacity for adaptive thinking were as essential to success as the rocket engines propelling them toward the moon. At the same time, the unknown loomed over every step of the mission. The lunar surface, while studied from telescopes and robotic probes, had not been experienced by a human foot. Questions abounded. Would the lander sink into dust, topple over, or encounter rocks too large to navigate? Could the astronauts move safely, plant instruments, and collect samples without jeopardizing the mission? The lunar module had to descend precisely to a chosen landing zone, a space smaller than a football field on a celestial body hundreds of thousands of miles away. The pilots had to integrate visual information, instrument readings, and their own intuition to avoid hazards while simultaneously managing fuel reserves that left no room for error. Every decision during descent involved a balance between physics and human judgment, a real-time application of thousands of calculations, some made by humans, some by the computer, some by a subtle combination of both. The astronauts became both operators and interpreters, translating abstract mathematical trajectories into practical maneuvers with astonishing precision. The psychological dimension of this challenge cannot be overstated. Landing on the moon was not a controlled laboratory experiment. It was a singular event, a high-stakes performance observed by millions on Earth, where failure meant tragedy and success meant history. The astronauts had to suppress fear, maintain situational awareness, and respond to unexpected anomalies instantly. Training alone could not fully replicate the conditions of lunar descent. Simulations could approximate trajectories, emergency procedures, and equipment responses, but they could not fully recreate the weight of responsibility or the adrenaline of actual danger. Yet, despite the unknowns, they succeeded. They transformed the unfamiliar into the navigable, the unpredictable into the manageable, and the impossible into the accomplished. This is a profound testament to human adaptability and ingenuity, illustrating how the mind and body can rise to meet challenges far beyond ordinary experience when disciplined, prepared, and motivated. Fuel management and precision landing illustrate another layer of the almost miraculous nature of the mission. The lunar module carried only minimal fuel reserves for descent, which meant the astronauts had to adjust their trajectory in real time, responding to subtle variations in terrain and unexpected obstacles. Too fast, and they would risk a crash. Too slow, and they might not reach the surface before running out of fuel. The fine balance between velocity, angle of descent, and landing site selection was a dynamic problem with enormous consequences. The astronauts had to process multiple streams of information simultaneously. Altitude, descent speed, fuel levels, surface slope, and the behavior of the lander's engines. Any misjudgment could have turned triumph into disaster. Their success was a combination of extensive training, innate skill, and the seamless integration of human judgment with technology designed to support but not replace the human element. Furthermore, all of this was executed with technology that by modern standards appears almost primitive. The guidance systems, though innovative, lacked the automation of contemporary spacecraft. They relied heavily on the astronauts' ability to monitor, interpret, and intervene. The human element was not supplementary, it was integral. Without the astronauts' adaptive decision-making, the mission would have been impossible. The synergy between human intellect and machine precision is a central theme in understanding why the moon landing was so improbable. It was a partnership, a delicate balance, where human creativity compensated for technological limitations and technological precision augmented human capability. Finally, the moon landing highlights the extraordinary coordination and collective effort required to manage such complexity. Mission control was a hub of activity where every calculation was checked, rechecked, and cross-referenced. Engineers and scientists monitored telemetry, predicted contingencies, and guided astronauts through every maneuver. Communication between Earth and the spacecraft had to be precise, timely, and clear, despite the vast distance and the inherent delays of signal transmission. A single miscommunication could have resulted in disaster. The mission's success depended not only on individual skill, but on the orchestration of thousands of experts working in concert, each contributing their knowledge and expertise toward a singular, almost impossible goal. The interplay of human cognition, technological innovation, and meticulous coordination across vast distances transformed an endeavor that seemed improbable into one of humanity's most celebrated achievements. Examining the timing, psychological, and operational aspects of the mission, it becomes evident that every moment of the moon landing was precarious, delicately balanced between success and catastrophe. It was not merely a feat of engineering or courage, but an extraordinary convergence of multiple factors: celestial mechanics, human psychology, physical resilience, technological precision, and collective coordination. Each element alone presented a formidable challenge. Together, they created a scenario that could have easily resulted in failure. Yet, against these staggering odds, humanity succeeded, demonstrating the power of preparation, ingenuity, and courage to overcome seemingly insurmountable obstacles. The moon landing is not just a historical milestone, it is a prophetic illustration of what can be achieved when intellect, determination, and creativity converge in harmony, revealing that the impossible is often only a challenge waiting for those daring enough to meet it. Even as humans approached the moon, they were venturing into the truly unknown. Despite telescopic observations and robotic probes that had scanned the lunar surface from afar, no human had ever set foot on that terrain. The surface remained a mystery, presenting countless potential hazards that could jeopardize the mission. Could the lunar module safely land on a surface covered with fine, powdery dust, or would it sink and tip over? Could unexpected rock formations or craters prevent a successful touchdown? These were questions that could not be answered definitively until a human arrived, yet the mission had to proceed. The astronauts had to rely on a combination of training, intuition, and real-time problem solving to navigate these uncertainties. The landing required delicate control, adjusting descent speed, angle, and thrust while simultaneously observing the terrain for hazards. Every decision was a dynamic interplay of physics, engineering, and human judgment. The moon's surface might appear static and serene from Earth, but to those descending toward it, it was a landscape of unknowns, demanding constant vigilance, rapid adaptation, and absolute precision. This element of uncertainty amplified the challenge enormously. It was not enough to plan a trajectory or design a spacecraft. Humans had to interact with a world no one had ever touched, making real-time decisions with minimal room for error. The psychological dimension of this uncertainty cannot be overstated. Imagine standing at the controls knowing that every adjustment must be correct, yet lacking complete information about the environment beneath you. The astronauts had to suppress fear, maintain focus, and act with perfect timing and judgment, all while managing communication with mission control and monitoring their spacecraft's performance. The ability to perform under these extreme conditions reflects the extraordinary adaptability and resilience of the human mind. Training simulated many possible scenarios, but nothing could fully replicate the experience of approaching a foreign celestial surface for the first time. In these moments, human intuition complemented scientific calculation. Astronauts made real-time judgments, interpreting visual cues, estimating distances, and adjusting maneuvers as needed. Their success illustrates the remarkable synergy between human cognition and the technology designed to support, showing that when faced with the truly unknown, prepared minds can transform uncertainty into achievement. Even more striking is the role of human creativity in responding to unforeseen challenges. Space is inherently unpredictable. Despite meticulous planning, spacecraft can behave differently under the actual conditions of lunar orbit and descent. Subtle variations in engine performance, fuel behavior, or gravitational effect could introduce discrepancies between calculated predictions and reality. The astronauts' ability to adapt to these deviations in real time, making fine adjustments to ensure a safe landing, highlights the unique capacity of humans to integrate observation, analysis, and action in ways that machines alone cannot replicate. This adaptability was crucial in turning a near impossible task into a historic success. Every step on the moon was a testament to human ingenuity, a living example of our species' ability to confront uncertainty and overcome it through intelligence, training, and courage. The moon landing was not simply a technical achievement, but also a demonstration of the human spirit. It required confidence to venture into unknown environments, skill to navigate them safely, and imagination to envision a path where none existed. The astronauts' steps on the lunar surface symbolized the triumph of human exploration, not because the technology alone enabled, but because humans actively directed, adapted, and responded to conditions that could not have been entirely predicted. The unknown was transformed into the known through a combination of preparation, observation, and courageous action. This principle, embracing uncertainty and responding with skill, intelligence, and creativity, is central to understanding why the moon landing was so extraordinary. Finally, the legacy of the moon landing extends beyond the immediate accomplishment. It represents a profound statement about the nature of possibility and human achievement. At the time, many experts doubted that humans could leave Earth, survive the journey, and return safely. The endeavor seemed impossible, constrained by physical laws, technological limitations, and the fragility of the human body. Yet, through determination, creativity, and rigorous preparation, the impossible became reality. This legacy teaches us that boundaries exist only until we challenge them, that the improbable is often only a threshold awaiting human ingenuity and courage. The moon landing is a symbol of what can be accomplished when intellect, collaboration, and daring converge in harmony. It reminds us that the frontiers of exploration, whether in space, science, or the mind itself, are limited only by our willingness to confront the unknown. The astronauts' achievement was not just a victory over technical obstacles, but a testament to the limitless potential of human imagination, discipline, and perseverance, showing that even the most formidable challenges can be overcome when we dare to venture into the unknown and trust in our capacity to adapt, learn, and succeed. The moon landing, therefore, is more than a historical milestone. It is a living demonstration of the principles that govern human achievement in extreme conditions. Every aspect of the mission, from timing and navigation to psychological resilience, technical precision, and adaptability, to the unknown, reveals the extraordinary coordination between human intellect and technological innovation. It shows that the frontiers of possibility are not fixed, but dynamic, shaped by the interplay between knowledge, courage, and creativity. The astronauts' steps on the lunar surface are a metaphor for the human potential to confront challenges that appear insurmountable, to adapt environments for which we are not naturally equipped, and to convert uncertainty into accomplishment through skill, determination, and courage. Each moment of the mission reflects an intricate choreography of physics, engineering, and human judgment, demonstrating that what seems impossible from one perspective can become achievable from another when preparation, intelligence, and audacity converge. The human experience on the moon also underscores the delicate balance between planning and improvisation. While simulations, calculations, and rehearsals laid the foundation for success, the unpredictable realities of space demanded that astronauts think on their feet. Each decision carried consequences not just for the mission, but for the understanding of what humans could achieve beyond our planet. The ability to make these decisions effectively illustrates the symbiosis between training and instinct, between technology and human judgment, and between knowledge and courage. The moon landing was not a deterministic outcome dictated solely by machines or plans. It was an achievement realized through the dynamic integration of human skill and technological capability, a living example of how exploration transforms uncertainty into knowledge and opportunity. In the broader context, the moon landing challenges our understanding of human potential. It demonstrates that even in the face of extreme uncertainty, when variables are numerous, risks are high, and conditions are hostile, humans possess the ability to adapt, innovate, and succeed. The combination of rigorous preparation, real-time judgment, and courage under pressure creates the conditions under which seemingly impossible tasks can be accomplished. The moon, once a distant object of wonder, became a reachable destination not because the obstacles were trivial, but because humans rose to meet them, transforming imagination into reality. This insight has implications far beyond space exploration. It speaks to the capacity of humanity to confront new frontiers, solve complex problems, and achieve what was once considered unattainable. The landing on the moon is also a profound lesson in the interdependence of human skill and technology. Each system was designed to complement the astronauts' abilities, yet no system could replace the adaptability, intuition, and judgment of a trained human mind. The mission illustrates that the most remarkable achievements occur not through technology alone, but through the integration of intellect, creativity, and courage with tools designed to extend human capability. The astronauts' ability to adapt to unforeseen challenges, interpret ambiguous data, and respond effectively under extreme pressure exemplifies the unique contributions of the human element in exploration. The moon landing is therefore not just a story of machines or physics, it is a story of humans. Imagination applied in a context where uncertainty is absolute and stakes are infinite. Ultimately, the moon landing represents the triumph of preparation, resilience, and daring over the limitations imposed by the unknown. It illustrates that human achievement is defined not solely by technical skill or physical capability, but by the ability to confront uncertainty, adapt, and act decisively in conditions for which we were not naturally designed. Each step on the lunar surface symbolizes a larger principle, that the frontiers of possibility are expanded when intellect, courage, and creativity converge. The astronaut's accomplishment stands as a beacon, showing that the improbable can be realized, that the unknown can be navigated, and that the seemingly impossible can be transformed into enduring achievement. It teaches that exploration, whether of space, science, or human potential, requires embracing uncertainty, leveraging preparation, and trusting in the capacity of the human mind and body to rise to extraordinary challenges. And so, when we look back at the moon landing, we realize it was not just a triumph of rockets or technology, but a triumph of the human spirit, the daring, the ingenuity, the courage to confront the unknown and turn the impossible into reality. It reminds us that no frontier is too distant, no challenge too great, and no dream too bold. We combine preparation with imagination, knowledge with bravery, and determination with curiosity. Every calculation, every maneuver, every step on that lunar surface was a testament to what humans can achieve when we refuse to accept limits and instead reach for the stars. As we reflect on this incredible achievement, let it inspire us not only to explore space, but also to explore the possibilities within ourselves. The moon landing is a mirror showing that the boundaries of possibility exist, only until we push against them. Let us carry forward the same spirit of wonder, creativity, and courage in everything we do, knowing that the extraordinary is always within reach when we dare to act. Thank you so much for joining me on this journey through one of humanity's greatest accomplishments. Your curiosity and passion for understanding the universe are what keep the spirit of exploration alive. Keep dreaming, keep questioning, and keep reaching for the stars. Thank you for watching.